Hello and welcome back. Today I am showing another update to the behavior building for the AI improviser. Today it'll be a pretty quick sort of update video, and then I hope to actually demo it with my guitar here in a kind of, I'm not sure what to call it, interlude video or something. Um, so, but what I wanted to show that I thought would be interesting today were not necessarily going through every behavior, but instead showing how I make the behaviors and save them as separate max patchers that are then called in as objects with arguments so that I can use all the different analyses with them. So you'll see here, it's not subpatcher, but just behavior underscore envelope follower, and then I have an argument of MFCC grain. So that behavior, it does envelope following of the live input, but using the MFCC grains matching for the following, for the triggering of samples. Before that, just one small thing that I added to the input analysis. So one thing that is very easy to do out of the box with the Flucoma analyses objects is matching, applying the labels, organizing, clustering the data, clustering the samples according to these different analyses as we've already looked at, and then querying using KD trees, which find nearest matches. So I also want to have contrast. So there's no KD furthest object. And so the way I deal with this is actually I manipulate the data on the way in. So here, for the mel bands, which you can see here, mel bands you see, if I whistle, it'll follow up the higher registers. Right, like higher frequency content is at the top, lower at the bottom. So what I've done at the input analysis stage is I've inverted the list of mel bands. So basically, bassy sounds will be interpreted as high spectral content sounds and vice versa. So that is, and then I do a K nearest search based on that, on an inversion of the mel bands. And then chroma is sort of interesting to do that sort of thing with. So I made 2 additional live buffers for chroma, which rotate the data. So right now, as a default, I have the chroma data rotated at the 5th and at the major 3rd. But one could do it anywhere within the 24 tone equal temperament chroma analysis that's happening. So right now, actually I can show this quickly. I'll have to load in a data set. Okay, so if we go into the behaviors, I have this chroma harmony one here. So so it's harmonizing around me because of those rotations of the chroma. Okay, so that's the only sort of utility that I added. A couple of small things within these objects as well, but not important enough to go over. But I wanted to show how to do this very useful thing of basically making a new max patcher and treating it as an object. So we can do that with this Euclidean rhythms one. So let me just move this up, make a little more space for what will be a few Euclidean rhythm subpatchers. So right now I have it as chroma slices, but if I want to, instead of copy and paste it and replacing every iteration of the chroma slices send objects, or where chroma slices is written in the send objects to get it to go to, say, chroma grains or mel slices or whatever, I can just create a new patcher, and then I'm just going to copy and paste in the entire subpatcher here. And then what I'm going to do is save it as behavior let's call it Euclidean save. And then wherever chroma slices appears, if I replace it with the number sign 1, then that will be the first argument when I instantiate it into the patch. So let me just get all of these. Okay, and then of course we'll need the label count as well to be proper. You also see that I'm giving it the pan and direction, but I'm not giving it gain or speed, which might be useful to add. And we can do that with another object that we already have, which is our note message object. And this, again, we can give it this first argument, and then in the subpatcher it'll get it as well. So we have an object within an object, or a patcher within a patcher. So we'll need, we can put this down here. Okay, so we have the gain. So let's say we want full 1 gain on, let's see, which is this coming from? This is at the measure. All right, so we get nice and loud at the measure. And then we can do a little softer for the subgroups. But in fact, we don't need to have separate note message objects. We can send it all to the same one. All right, so that can be 0.5. This one can be, let's do 0.9. So we'll have some differentiation coming out of the gate there, coming out of the gate there, and coming out of the gate here, and all going to the gain of the appropriate object. So, and then speed, I think we're going to always want it to just be at the normal speed. So that can go into all the gates, like so. And in fact, just to be thorough, I'm going to wait for that. I'm going to actually replace it with trigger bang bang after. Okay, so, and then we have our pan. So is the third one pan? The third one is window shape. Let's just have that consistent at 0.9. Oh, we don't need to load bang that. And then direction. There, there. So whether it's played forward or in reverse. And then finally our pan. Great, so we have all of our sends now to the note message object. And now let's get this to be a little bit more efficient with trigger bang bang at the gate here. We don't need, oh, we do need that, but coming out of, oops, out of there. So we'll give it the basically our note message. Oops. Still need that, but it should come out of here. That already shows up correctly there. And of course we need to bang out those three as well. All right, so we have a complete note message sent there now. Okay, a little messy, but that'll work. Clean it up a little bit. Great. Now let's bring the second one over. And we'll also want trigger bang bang. Oops. Stick it here. That goes to our loudness, as well as the other settings for that. and our drunk and our decide, if it's forward or backwards. Label count I don't need to have repeated like that. I can give it to all three of the random objects like that. All right, let's bring this one down and add the trigger bang bang, and then we're done sort of optimizing and making this into an object. So we need that like that. That goes there to that. We also want to send the speed and a window shape. Drunk and decide as well. Clean that up a little bit. Put that down here. And let's clean up the wires. And there we go. All right, so that should do it. So it's saved. Let me make sure I didn't miss any send or receive things. Okay, great. So I'm going to close that. So it's called Behavior Euclidean. So now we should be able to just go behavior, Euclidean, and let's try MFCC grains. And in here, and great. Super. So let's get rid of our non-easily duplicatable version, and we'll go to this version, and let's say chroma slices. I mean, this one's going to be better as slices in general because it's rhythmic. MFCC slices, and let's do chroma slices. Oh no, we have chroma slices. All right, let's do mel slices. So we have all these behaviors now. I'll probably make a few more as I experiment with the patch. And so then all we need to do now is figure out how to move between the behaviors and how to integrate the sort of saving and loading of corpus data, which will come soon. The other thing that I wanted to add to this improviser before it's totally done is processing. And I've done this already in terms of delays, but I feel like that is maybe better as a separate video. So for now, I'll sign off. I'll have another video on delays and processing, and maybe trying to get just the audio routing up to snuff in this patch. And then after that, or maybe before that, I'll make a little sort of demo of actually playing some music with these behaviors. All right, thanks for listening.